Atari 2600 is a game console released in the late 1970s. Even though the graphics were not particularly magnificent, the Atari platform was popular, and there are currently around 400 games available for it. This collection includes immortal hits such as Boxing, Breakout, Sequest, and of course, Space Invaders. In 2013, the DeepMind team invented an algorithm called DeepQ Learning. It learns to play Atari 2600 games using only the input from the screen. Following a call by OpenAI, a lot of work has been published on the Atari games, as it has become one of reinforcement learning's standard test sets. From testing new different algorithms and approaches to reinforcement learning, to using the RAM bytes directly as the observation instead of image frames. We will approach the Atari games through a general framework called reinforcement learning. It differs from supervised learning and unsupervised learning because it utilizes two separate entities to drive the learning. The agent, which sees states and rewards and decides on actions, and the environment, which sees actions, changes states, and gives rewards. In our case, the environment is the Atari machine. The agent is the player, and the states are the game screen. The agent's goal is to maximize the discounted sum of rewards during the game. We use stable baselines, which is a set of improved implementations of reinforcement learning algorithms. Instead of estimating the quality of a state-action pair like in Q-learning, we use the PPO policy gradient algorithm, which directly optimizes the policy, that is, the way the agent behaves. Each one of us trained agents for two different Atari games with PPO to later generate a dataset of trajectories for each game. However, due to limited computational power and time, our trained agents still perform poorly after some days training on gym environments. To overcome this issue and create trajectories of expert behavior, we ended up evaluating and using pre-trained agents distributed by RL Baseline Zoo. The idea for our project came from one of 7 unsolved problems published by OpenAI last year. The problem is to evaluate whether or not we could fit generative models such as variational autoencoders or, more recently, a transformer network to the trajectories generated by agents trained on Atari games, and then use it as a policy network for a different game after some fine-tuning. More specifically, OpenAI's goal was to quantify the benefit from pre-training the generative model on different games, prior to the one we're interested in learning the actions for, and then to evaluate if it'd be possible to use less training data for it because of transfer learning. Since OpenAI's suggestion was to use transformers. No, not this one. The recent neural network model that has become the new favorite for language processing tasks, particularly for sequence transduction. Thus, our aim was to use the trajectories we've collected and fit the model to essentially translate Atari image frames to a sequence of good action. Unfortunately, since the transformer applications have text input and output, and in our case, we have image input and a small set of agent actions as outputs, their dimensions don't match. So we tried re-implementing the transformer network to work with it, but we didn't succeed in fixing the residual connections and embedding layers fast enough to be able to train our implementation from scratch. Hence, we conclude the project with a good collection of state-to-action mappings of expert agents on Atari games to serve as a base for tackling this unsolved problem.